Welcome to the Programming Electronics Academy podcast. Join us every other week as we explore how everyday people are creating extraordinary things in the world. Find us online at programmingelectronics.com.
Hello, I hope you're doing fantastic. Thank you so much for joining me this week. Today's show is pretty sweet. We're speaking with Gabe Bentz. He's the founder of Slant Concepts. They do a bunch of different stuff, as you will learn, but one of the things they're working on lately is Little Arm. It is a desktop robot arm that is just about fully 3D printable and is just pretty neat. We'll learn quite about it, so I won't talk too much about it now. All right, let's go ahead and get started. Hello, Gabe. Thank you so much for taking the time to talk. I really appreciate it.
No problem. Thanks for having me.
I'm excited to talk. You have a ton of stuff going on. You're the founder of Slant Concepts, and most recently, you're the creator of Little Arm. And you just got a lot of stuff going on. I want to learn about it. But before we dive into those things, I'm kind of curious about what got you into this kind of prototyping with electronics and obviously a lot of the programming stuff that you're doing. I'm curious what got you along that path.
Well, I can't remember. I've always been interested in robotics. That's always been kind of the main driver for anything that I've done. I can't remember a time when I haven't been interested in it. When I was going through high school, I grew up on a cattle ranch, so it was easy to facilitate building things and working with stuff because I was always working with tractors and heavy equipment. I could weld when I was about 6 years old because I had to. It was just kind of the nature of the job and the living and the family and everything else. And as I progressed through school and everything else, I kept on adding the technology to it, the programming and the real hard technology. And it's just been a continuous hobby my whole life, just around robotics and engineering and design and everything else. So it just always has been.
That's cool. When did you start getting into Arduino?
I probably started hitting Arduino pretty hard. About freshman year in college was when I really started working with it. I discovered it in one of my electronics classes, and then I kept on playing with it myself.
That's cool. I was looking at the Slant Concepts website, and you have the coolest portfolio of projects on there. I just got to say, like a huge variety of stuff, like including a radio-controlled giant tractor, which I thought was pretty sweet. What you claim you did it for under what, $260, which was pretty impressive. But
yeah.
So it's just a lot of neat projects. Are a lot of those projects, those are the type of things you've just naturally just kind of gravitated to, grown to working on and stuff?
Yeah, pretty much.
That's cool.
Like the project with the tractor was actually something that a neighbor had asked me to do there on the ranch. He was out where I grew up. We feed hay off of the back of wagons by hand. So he doesn't always have a driver. So he wanted to be able to steer his tractor and throw hay off the back of the wagon. So he asked me, "Hey, Gabe, you're an engineer. You can do this, right?" And I was like, "Sure, whatever." And so I went on Amazon and started finding a bunch of loose parts, and I was able to stick something together that he could semi-understand and fix if he ever wanted to.
That's nice. That's great. So let's start talking about Little Arm. Could you kind of give a verbal description of a very visual tool?
The Little Arm itself is a fully 3D printed micro desktop robot arm. It can be controlled through a USB port on your computer where you use scroll bars basically to control the individual joints, and that's pretty much it. It's got a reach of about 10 inches, so we're talking pretty small. The original one used an Arduino Uno to control itself, and the newer ones use the Arduino Nano. That's the general description of it. I designed it in a garage on a weekend, basically as just a project to mess around with. But at Slant, we're always designing new things or whatever it is. So I brought it in to show to the rest of the guys, and they were like, "Okay, we got to try this out for real." And I was like, "Guys, I was not a fan of 3D printing for a really long time. So I was not excited to professionally take on a 3D printing project. Because personally, 3D printing was silly to me because I was like, okay, you do the prototyping and everything else, but as far as production or creating a product, it just didn't make sense to me. But we did it, and we stuck it up on Kickstarter, and the darn thing did pretty well. So we turned it into an actual project at the company anymore. So that's kind of how it came about.
Oh, that's cool. So why? So you had a 3D printer, so you're like, hey, let me just go ahead and 3D print it. Is that how it went about? Was it initially prototyped with 3D printing?
Yes, it was initially prototyped with 3D printing. I do have one at home just for that purpose every once in a while because they are good to whip stuff off real quick. But it was mainly a project just to work with the Arduino, and since we were working on other robotic arms at the time, I wanted a really small demo that I could run some really jinky code through and not worry about breaking a really expensive robot arm. So that's kind of the reason for the creation of it in general.
That's cool. What is the target audience for a robot arm like this?
We try to make it as accessible as we can for kids about 6 and up, because it's a really easy way to get a fully comprehensive exposure to engineering and design in general, because they can design parts for it in CAD, 3D print them, 3D print our existing parts, and then program it, see how all the mechanisms and gears come together. So robotics in general is a really good thing for kids to learn about engineering and all the other disciplines within it.
Okay, I got it. And so is it programmed with, like inside the Arduino IDE?
Yes, it is.
Okay. And is there like a library specific to the ARM that people are using?
Not a library. We just keep a series of code samples going up on the website that people can download and work with.
Okay. And so what actually moves the ARM around? Is it like stepper motors, servo motors?
We use MG90S micro servos.
Okay, that's pretty cool. So it's not. It's obviously it's a smaller arm then, right? That's not like a huge heavy duty servo or anything.
No, they are all. It's 4 MG90S servos, and since it was 3D printed, it was light enough to allow us to use those all the way down to the base of the arm, where normally you'd need something beefier.
Okay, that's cool. What have people been using them for? Have you seen some interesting stuff people have been up to?
You know, I just found a video about a week ago that came up. I can't remember the guy's name who posted it, but it was Robot Beats the Robot CAPTCHA on YouTube, and he took one of our arms and he has it move the stylus across the keyboard or the tablet, whatever it is, and tap "I'm not a robot" on the CAPTCHA and beat it, and then it goes through and the little meme sunglasses come down on the robot and everything else. And that's probably the biggest video that I've seen with it. And it's not that great of a demo technologically, but it's one of the funniest things I've seen.
Oh, that's hilarious. I love that. We'll make sure to link to that in the show notes. Just on YouTube, I imagine. Cool.
Yeah.
So what are the other type of things you guys are up to at Slant Concepts? So actually, if you could just fill me in a little more about Slant Concepts and what the company's about and who you serve and what you do.
I started Slant Concepts about 3 years ago in a college dorm room. I needed to make extra money, and since I had been doing work for other people just in general, because, you're an engineer, do this, because you must can, or whatever it is. Or you obviously can, even though engineer is kind of like being a doctor. People always show you something, even though you may not have any idea what it is. But I decided to kind of become a semi-consultant and charge people for this stuff. So I do CAD form or engineering, and it turned into Slant because as I would freelance with this stuff, I would find other people to join me, and we'd meet online and we'd trade stuff back and forth. So if I wasn't a very good developer, but I had a project where we needed an app or something, then I had a couple of friends who I would call. Right now, Slant is myself and a bunch of those guys who I've kind of collected over the years from these collaborations on different projects. The main guy anymore, one is in Hong Kong, the other one is in Texas, and we basically video chat whenever we have to go through things to work on these various projects. And then I do kind of the manufacturing and fulfillment now in Nampa, Idaho. I moved the Slant to Idaho about a year ago, and that's when we changed from a consultancy and working on individual projects that people brought to us to kind of our own projects. The very first one we did was way more ambitious than we should have attempted right at the beginning, but it was a lot of fun. It was a home robot, and we had solved all the vision problems and come up with all kinds of neat little ways of working with it, making it possible. But our prototype was pretty jinky, and it just turned into a project that was going to be more expensive than we wanted to pursue right now, and convincing people that we had it working the way we said we had it working. And we couldn't do enough demos to prove that it was working right. So that project kind of went to the side, and near the end of that was when I created the prototype for the little arm. And in the past, we had run a bunch of Kickstarters, so whenever we had something new, we'd stick it on Kickstarter to see if anybody cared. So the guys convinced me to do that, and we stuck the little arm on Kickstarter, and it has since gained enough of a following that it's a big part of what we do anymore in developing the little arm community and products around it. And then on the side, we always have the other robotics projects because we want to be in real practical robots. We're great with it. We like the toys and we're fine with the toys and everything else, but we do love it when you see a robot do something truly useful inside the real world. So we try to work back towards that as much as we can. So we had like the shop arm, which was a large 3D printed SCARA-based arm, which is basically an arm that works in a horizontal plane. It's got two links at the elbow and at the shoulder, and then it raises straight up and down. So it's got a cylindrical workspace. And then we had a couple others in between there. I can't remember all the projects now.
That's cool. So the shop arm, it can like do a whole loop around that pole then? Is that?
Yeah.
Okay. Well, that's pretty neat.
Yeah.
I didn't realize that. I was watching some of the videos on it because it reminded me in some regards like the little arm. But I guess all robot arms might remind me of the little arm because, I mean, they're, joints and hands and stuff. But I didn't realize that it had that full rotation around that cylinder in the center. So that's pretty useful. That's kind of neat.
Yeah.
How far does that arm reach out?
The sharp arm, I think it had a reach of 14 to 16 inches total.
Okay. Wow, that's cool.
But decent.
So, yeah, you were talking about different robots that you guys are working on for practical use. So you kind of ended with the shop arm. Were there others in development that you guys have planned right now? Or?
The shop arm is kind of still a focus. We stuck it up on Kickstarter and it failed there, mainly because we rushed it a little bit too much. If you watch our videos, most of them are rough. In a nice, if I'm to be gentle to myself on that, they're rough. But we're working on improving the software for it on the side and everything else. We also have about 3 other projects coming down the pipe. One related to Little Arm, one about, no, that one's not available yet. We're not going to talk about that one yet. And then just the 3D printing, because when we started with the Little Arm, like I said, we weren't interested in 3D printing at all at that point. But when we made the Little Arm, we had to produce it, and no one has a printer farm really that you can just call and have your things manufactured for you. So we've had to create a printer farm for ourselves that's now so big that we're kind of farming it out, and that's become its own project of its own. And that's called Slant 3D right now, and we just made it available. But that's a new thing taking my time that sprung out of Little Arm because we had to manufacture the little arms, and 3D printing farms don't really exist.
Huh, that's awesome.
It's interesting.
So what would you say? You're obviously doing a lot of interesting stuff here. What would you say is the toughest part about designing these things and kind of getting them out there?
Starting out, the biggest thing that we ever really ran into was just making something that anybody cared about or wanted. Because since most of us are engineers automatically gravitate to the things that are cool and making them cooler continuously, which is basically a unfulfilling prophecy because you're never going to hit the perfection that you want to meet. So the toughest thing for us is really narrowing down where to stop and what we want the thing to do so that it's very clear when the project is finished and when it's presentable. And then just in the presenting of it, the marketing and the overall, just the marketing. I can't think of another word to go along with that one. But the marketing and selling of it can be tough because it's an artistic and different side of the brain than engineering most of the time.
Yeah, absolutely. When you were getting into electronics and programming and I guess 3D printing too, what were some of the challenges you had? I guess you've been kind of into it a long time, but did you have any challenges along the way when you were kind of trying to grasp some of these concepts? Or?
Oh yeah, I hate electronics and still do. Always have, always will. And it's really tough when you're a roboticist. But the toughest thing for me has always been electronics because it's kind of an oogie boogie side of engineering to me. Because if something goes wrong, you cannot find it. In a mechanical design, you can see the wheels broken and dig into it. And in software, you can kind of track that backwards too and debug fairly easy. But you can't tell when a resistor is just a little bit off or something like that, and it's giving you weird readings. So the hardest thing for me has been the electronics and gaining the patience and the overall skill set just working with that. That's been my biggest challenge in my life, I guess, working with this stuff. and I try to avoid it as much as I can still. So
I love this honesty. It feels good to hear that. I'm not the only one out there who struggles with stuff. So what would you say is a big kind of benefit, or, well, how do I want to rephrase that? What would you say is like a big success story that you've had with Slant Concepts lately?
Oh man, I actually right now I really need to point towards the little arm, because I consider it a much bigger success, because initially we didn't really care about it and it was still a success. And I think that's awesome, that something we weren't totally behind and super passionate about at the beginning did so well. And now we've continued to revamp it and grow it into something that we're really proud of. And now it's turned into one of the favorites here anymore when we're working with them.
That's awesome. Do you have future plans for the little arm, like making it a bigger arm or anything like that?
Well, we have already done that. About a month ago, 3 weeks ago, we finished up the Kickstarter for the Little Arm Big, which is a 6-axis robot arm that's based on all the same software and foundations as the Little Arm. The Little Arm is only a 4-axis. It has 4 servos moving the shoulder in 2 directions, the elbow and the gripper. The Little Arm Big it's a lot bigger. It's about 2 feet long. It's fully 3D printed still, just like the little arm. And actually, the end of it is the same as the little arm. A couple of the joints at the very end are a cropped part of the little arm. And all the apps and everything else operate the same. We'll be delivering it in about 2 months. We start the deliveries for the Kickstarter and hope to have it available by the end of the summer to the general public who weren't backers right away.
Awesome.
So that's for the little arm. And then one of the newer projects that we've got is actually called Little Bot, which is a 3D printed mobile robot that wanders around and uses the same board and a lot of the same sensors and controllers as the little arm. So it's going to be a mobile brother too, or cousin, I guess.
Oh, that is so cool.
So it'll be fun.
Does the little arm, does it have its own like battery pack that goes with it, or how does it get its power?
Generally, with the kits anymore, we have just a 6-volt power supply that you plug into the wall, and then it plugs directly into the little arm. If you want to, you can get a 6-volt AA battery pack with 4 AA batteries, and you plug it into the back of the board, and that'll work just fine too.
That's nice. So the Arduino, is the Arduino provided as part of the kit that when you buy it?
It is.
Okay, gotcha. And then this just wires it. The Arduino basically just wires into that board you were referring to.
Yep, you plug the Arduino right into the board.
Okay, nice. So it's like a shield then, essentially on top. Okay, gotcha. All right, cool. Oh, that's awesome. And so why the switch to the what did you say? You went from the Uno originally to a different board?
Yeah, we went to the Nano. The Uno was just kind of overkill. We used it on the original one because the stock Uno has pins that are really easy to plug into, and we were using a breadboard and an Uno, so it was a good thing for kids to see the electronics there. But we found out that the breadboard and the Uno, even though it's easy to adapt, it's not a good thing to allow that in there when a kid has no clue what they're doing. So it's good to direct them a little more. So when we went to this new board, he was using a Nano, and it's got fewer pins, it's cleaner, it's simpler, and it just focuses people down to what needs to be done and away from things that could screw stuff up while they're building it.
That's cool. Yeah, sometimes having limits or constraints can actually be really helpful, I think, when you're trying to learn something. So if I wanted to program the little arm to do something, can I walk it through what I want it to do, physically take it and move it and train it myself? Because I think of trying to figure out conceptually or programmatically, I'm not saying that word right, but you know what I'm saying, to try to program I want you to go from here to here in the most minimal servo movements possible. That would be, in my brain, that seems tough, but I'm curious how you guys handle that or how that's handled.
We don't have a manual way of training the arm. You can't grab the end of the arm and drag it around. there's servos out there that have an analog feedback that gives the signal back to the board so that you can do that kind of manual manipulation, but they're super expensive, so we don't use them in the little arm, and kids would break it anyway because they start jerking around too fast.
Kids break everything.
They'll break everything pretty much. But what we do with the little arm is you can train it in that kind of a way using either the Bluetooth app or the Windows app. By just controlling the joints, you move each joint individually, and you record waypoints, which are the joint positions of the shoulder, the elbow, the gripper, so on and so forth. And then you can build up this little list of positions, and then when those are fed into the little arm, it smooths it out and combines them all so that it's not the perfect solution for the shortest distance between 2 points, but it gets pretty close, and it makes the arm move fairly smoothly.
Wow, that is a really neat way to do it. Is that a common method for programming robotic arms, or?
The way of training it, or the way?
Yeah, I guess the way of training it.
No, not really, because in most real robot arms, using a scroll bar on each joint is just too labor intensive, really, to make it worth the effort. So, like large industrial robot arms. That programming can be a nightmare and go super deep, but they mainly go with just the waypoints. Like, you need the arm at this point in three-dimensional space, and then you need it in this point in three-dimensional space. And then the software itself cleans up all the motions of the joints inside there, whereas we have you moving the joints individually and controlling that direction, which is slower. But for a 4-axis arm, it's good, and kids get to see how the actual joints combine to create a motion.
That's cool. And how can people, it appeared to me that people can kind of accessorize the arm. What type of accessories, or expand, I guess. Maybe expand is a better word. What are some of the expansions that you've seen?
Well, the easiest ones are the grippers. We traditionally have just a normal pincher gripper that you would kind of expect from a robot. But then you can add a wrist to the end and then use a hook or like a snap for a Sharpie, so you can do like really simple drawings. It's not something you're going to be doing some kind of upload a picture and then you draw it with this robot arm. The little arm doesn't have the capabilities to do that very well, at least not that I've seen yet, and we haven't worked on anything like that. The other expansions are you can add in, like with the newer arm, you can plug an ultrasonic sensor right into it, so you can record a sequence, upload that to program that into the Arduino, and then you can use the ultrasonic sensor as a trigger for that sequence. So you're like, I want something in my coffee cup. You can set the cup in front of the sensor, and then the arm will go and grab a packet of sugar and drop it in there, or a sugar cube and drop it in there for you. Or you can use the sensor actually to control the arm, and we do a couple of really simple demos where you use that single sensor to see your hand, and then the arm moves up and down as you move above the sensor, which is a nifty little demo. And then if you want to go super advanced and want to play with 3D space and mess with kids' heads, there's the sensor cube, which is 2 ultrasonic sensors and 1 infrared sensor that point in the 3 dimensions, X, Y, Z, so that you have 3-dimensional control of the arm. And then you can use your hands or a pad or something to move the arm in 3 dimensions using this cube. And it's not natural or intuitive at all, but it's like dragging the arm up and down in a 3-dimensional axis.
Wow, that's really cool.
It can be fun, but yeah, it is frustrating. It gets frustrating really fast.
Well, this is neat. So have you demoed it at like a Maker Faire or anything like that?
We have not yet. The whole little arm family is only about 8 or 9 months old right now. We'll be going to Maker Faire in San Diego or San Jose this summer. So May 20th, I think, is when it is, 18th through 20th. But yeah, we'll be down there with all of these. That'll be our first really big expo. We've gone through to a few STEM conferences and stuff where kids can play with them, but Maker Faire will be the biggest one we've done in a while.
That's awesome. Cool. Well, Gabe, thank you so much for taking the time to talk about Little Arm and a little bit about your background and Slant Concepts. I really appreciate it.
No problem, Mike. Thanks for having me.
Sweet. Absolutely. Take it easy. Well, I wasn't exaggerating. Gabe really is up to a lot of interesting stuff, and that's pretty cool. I really appreciated his honesty, talking about the challenges he has. You know, so many of us have challenges learning different stuff. Some things for us come easy, some things don't. but I really feel like, to me, it feels like he's got the grit to kind of work through those things and work with other people who do have that expertise. So that I admire that. I think that's sweet. So, hey, if you haven't yet, I would love for you to subscribe to the show. Every 2 weeks, we release a new show. It'll show right up in your podcast feed. And also, if you could take the time to rate and review our show on iTunes, I'd really appreciate it. I hope you have a wonderful rest of whatever you're up to right now. And I look forward to speaking with you next time. Bye.
This show is produced by Programming Electronics Academy, an online technology education company. We exist to help you create the technology you want in your life. If you are interested in learning more about Arduino, we welcome you to sign up for our free Arduino Crash Course, a 12-part video series with accompanying written lessons designed to teach the basics of programming Arduino. To register for the course, simply text your email address to 440-701-5311, or you can visit programmingelectronics.com and sign up there.